Hey guys, today we are going to talk about inverses. So if you have a function and then you find the inverse of the function, then the inverse of a function is kind of like the same function except it's working backwards. So a way that you can think of it is like if you have a function, then its inverse is going to undo whatever the function just did. So an example of that is like if you have x plus 5, say that x equals like 4. Then if you do 4 plus 5, that equals 9. But then if you have the inverse, and you have x minus 5, then you have that 9 from your x plus 5, and then you take it back away again. So you get back to 4. So you just end up back at the beginning, kind of. So with that being said, whenever you have these inverse functions, it's going to switch your x and y coordinate. So let's pretend you have a function f of x, and it has the point 2, -1 on it. Then if you take the inverse of that function, which by the way, the inverse looks like f, and then there's like a little -1 that looks kind of like an exponent, that's called f inverse. But the inverse of f of x, it would have the point -1, 2 on it. So you literally just take that x and y and switch them. So that's just something to keep in mind as it switches those x and y coordinates. And on a graph, a function and its inverse are going to reflect over the line y equals x. So that's something that we're going to look at a little bit more in a minute or two. But let's keep going on just, what these inverses are and what they do. So the main thing that you guys are going to be worried about is how to find inverses. So the first step that you need to do in finding inverses is switch x and y. So I have this example down here. So I'm just going to switch x and y in this equation. So don't overthink this part. You literally just like where you see a y, write an x, and where you see an x, write a y. So now you have x equals 2y plus 3. And then the only other thing that you need to do is just solve for that y. So to solve for that, it's kind of just like whenever you have a regular equation and you're solving for x or you're solving for some other variable. You just need to get y by itself again. So to get y by itself in this equation, the first thing that we need to get rid of is that plus 3. So we're going to subtract 3 from both sides. And now on the left-hand side, we would have x minus 3 equals 2y. And then the last thing that you need to do to get y by itself, or to solve for y, is just divide by 2. So now you would have y equals x minus 3 divided by 2. Or if you wanted to simplify it out further, it could be like 1/2 x minus 3 over 2. Or either one of those would be fine. Both of those would be correct, and they would both be the inverse for y equals 2x plus 3. So then I just want to do a couple of examples of actually working these out. So we're going to start with number 19. And so we talked about earlier that you have like f of x and f inverse x, but we also said that the first step is to switch x and y. So if you have it written as f of x, you can just take that f of x and know that it's referring to y. So right now you have y equals 1/6 x. But then the first step whenever you're trying to find the inverse is to switch that x and y. So you can change that to x equals 1/6 times y. So then we just need to get that y by itself, but we have a 1/6 in front. So I don't know if you guys remember from past math classes, but when you need to get rid of a fraction in front of a variable, then you would just multiply by the reciprocal. So the reciprocal of 1/6, that's just the fraction flipped upside down. It would be 6 over 1. So what you're going to be doing is multiplying both sides by 6. So then 6 times x is going to be 6x on the left-hand side, and that is going to equal y. And then that's it. Y is by itself. If you want to just rewrite it so that the y comes first, then you can. but that would be the inverse for number 19. So then let's do number 21. We're going to just rewrite that f of x as y. So we have right now y equals x squared minus 2, but we need to switch the x and y. So we're going to rewrite it as x equals y squared minus 2. And so then we need to solve for this y in here. So the first thing that you need to get rid of is going to be that minus 2 that's at the end. So we're going to add 2 to both sides. And I'm going to have x plus 2 equals y squared. And then whenever you're trying to get rid of a squared or any exponent, you're going to have to take the root of that. And so to get rid of a square, you're going to have to take the square root. So the square and the square root are going to cancel each other out, and you're going to just have y on that right-hand side, and it's going to equal x plus 2. And then anytime that you take an even root, like a square root, you need to put a plus and minus in front of the square root sign, because it could be like a positive or a negative version of that. So you would just have y equals plus or minus the square root of x plus 2. And then I want to do maybe one more. Let's do number 23. And so 23, let's change that f of x to y. And so we would have y equals the square root of x minus 1. So this is similar to the last one that we just did, except we're starting with a square root. So, and I should have gone ahead and done this in the last step, but the first thing that you need to do is still switch x and y. So let's rewrite it as x equals the square root of y minus 1. And now, like we talked about before, we need to get rid of a square root this time. So the opposite of a square root is going to be that squared, or like raising something to the second power. So let's go ahead and raise both sides of this to the second power. So now you would have x squared equals, and the square root and the squared are going to cancel. So you would just have y minus 1. And then we just need to get rid of that 1. So let's add 1 on both sides. And we would end up with y equals x squared plus 1. And so that's really it on all of these. You're essentially just gonna switch x and y and then perform operations on both sides to keep the equation balanced, and then just make sure that you get y by itself again, and that's going to be the inverse of the original function that you had. Okay, so on these couple of examples here, it's asking us to graph each function and its inverse on the same axes, or on the same graph. And so we're actually going to graph it on Desmos so that you guys can see a little bit more about it. But let's go ahead and find the inverses here, and then we'll graph both of them. So I'm going to change that f of x to y equals x plus 5. And then to find the inverse, I'm going to switch my x and y. So I would have x equals y plus 5. And then I just need to get rid of this 5, so minus 5 on both sides. We would have y equals x minus 5. So that's going to be the inverse of that one. And then we need to do number 16. So we have y equals 8 minus 2x. And so we're going to switch x and y. So I would have x equals 8 minus 2y. And then the first thing that we need to get rid of is this 8. So let's subtract 8 from both sides. And that's going to equal negative 2y. And then we need to divide by the negative 2 to get rid of that. And so we would have x divided by negative 2. That can be written as just negative 1/2 x. And then negative 8 divided by negative 2. the negative divided by negative is going to become a positive, and then 8 divided by 2 is 4. And then that equals y. So that's going to be our inverse for that one. So then we're going to go over to Desmos, and we're going to graph both the original functions and the inverses on the same graph so that you can see what that looks like. Okay, so I'm on Desmos, and I've got my functions typed in, and I went ahead and graphed the line y equals x because, like I was talking about earlier, it's going to reflect the two functions, the function and its inverse, are going to reflect over this line y equals x. So my first two are x plus 5 and x minus 5. So let's turn those graphs on. And you can kind of see here, it's reflected perfectly over that line y equals x. That's just because it has the same slope as the line, so you can see that it's reflected. And then you can also see the original function has that point, 0, 5, so then the inverse function has the same point except with opposite coordinates, so it has 5, 0. And then same thing like here, the original has negative 5, 0, so the inverse is going to have 0, negative 5. So that's one cool thing that you can see on Desmos. And then let me turn those back off. And this was our second one. And so this one's a little bit cooler where you can see like how it's reflected a little bit better. And then you can also see like there's a point at 2.67, where both the original function and the inverse, they intersect on the line y equals x at that point. So that's kind of cool. And then you can do the same thing, like this one that I just hit is actually the inverse function. So the inverse has 0, 4, but the original has like 4, 0 and stuff like that. And so then I also just want to show you guys one that looks a little bit cooler. So what I'm going to do is I'm going to graph y equals x squared. And so then that just gives you a parabola. And so then for it to have its inverse, like we were talking about earlier, you would have to take the square root of x squared. So the inverse is going to be y equals the square root of x. And then right now, this is not like reflected like we were talking about earlier. It's not reflected over the line y equals x because this is only like half of a parabola. And so, like we said earlier, whenever you're taking the square root, you often have to put that plus or minus sign in there, which I'm not sure if we have that on the keypad. Let me see if I can just get it on here. I'm not seeing it. So instead of doing that, we'll do the positive version of it. And then I'm going to come down here and also do the negative version of the square root of x. And then I want those to be the same color. Sorry guys, technical difficulties. Okay, so that's better. So now you can see you had this original function as a parabola, and then the inverse, if you're using the positive and negative version of the square root of x, it reflects perfectly over that line y equals x, and you see this little sideways parabola. One thing to note on this is that the sideways parabola like this, where it has the positive version up here and the negative version down here, that is not going to be a function anymore. To be a function, something has to pass the vertical line test, which means if you have a vertical line on the graph, for example, x equals 3, and that's just a random example. But if you have a vertical line on the graph, it can't touch your graph in two separate points. And on this one, the sideways parabola, it does. So that means that would not be a function. So that's just something kind of to keep in mind. Not all inverses are going to be functions. And in this case, it's not. But that is just kind of a cooler looking example than just the lines that we had been doing previously. All right, and then the last thing that I want to do is just kind of a more real life type example. So like real world stuff. So this problem, it tells us the formula for the volume of a sphere is volume equals 4/3 pi r cubed. So that is cool and all. And so now we have to find the inverse of that. So one thing that I want to make a note of is whenever you have something like this, you don't want to switch the V and the R because that would be saying that the radius equals 4/3 times pi times the volume cubed, which is not accurate. So in cases like this where it's like a real world example, you can skip that first step of switching the two letters and instead you can just solve for the other letter. So right now we have V equals 4/3 pi r cubed. So, working in order, we need to get the r by itself. And the last thing we're going to be able to get rid of is the cubed. So the first thing that we need to do is get rid of the 4/3. So like we were talking about earlier, to get rid of a fraction in front of something like as a coefficient, you just want to multiply by the reciprocal. So the first thing I'm going to do is multiply by 3/4 on both sides. So then if you multiply the volume by 3/4, what that is going to kind of end up doing is you're multiplying the volume times 3 and then dividing it by 4. So the way that's going to look is 3v over 4, and it's going to equal pi r cubed. So then this is where it might start to look a little bit weird, but the next thing that you need to do is get rid of the pi. So I know that pi, it looks like a symbol, and it doesn't look like something you can just divide by, but you can. Keep in mind that pi is just a number. It's 3.1415, etc. And so what we need to do next is get rid of pi in front of r cubed. So we're going to divide both sides by pi. So the right-hand side is now just going to be r cubed, and it's going to be equal to 3v divided by 4 divided by pi. So the way that that's going to end up looking is the 3v divided by 4 pi, because it's being divided by 4 and is being divided by pi. So the pi can just go down there on the bottom with the 4. And then it equals r cubed. So the last thing you need to get rid of is the cubed. And we talked about earlier that anytime that you have an exponent, you need to take the root of that exponent. So in this case, we need to take the cube root. And so that looks like the square root sign, but there's a 3 out front. And so then the cube root gets the r by itself. So now we can write r equals, and then we have the cube root of 3v divided by 4 pi. And that looks really long, but that's going to be the answer for the inverse on number 7. All right, so now the last thing that I need to do is I need to use the inverse to find the radius of a sphere that has a volume of 35,000 feet cubed. So in other words, we have our equation. We know that volume is 35,000, so that means V equals 35,000. So I'm going to write that out. Okay, I don't know why it stayed red. It's fine. So I'm going to have R equals the cube root of 3 times our volume, which is 35,000, divided by 4 times pi. And then obviously you would have to type that into a calculator or use an internet calculator or something like that to actually solve it. I just copied a screenshot of it and I'm hoping this is going to work. Okay, it did. It just worked really big. But again, that is okay. So this is what it would look like if you typed it into a calculator. And so that gives you r equals that 20.29, and then it tells us that it's in feet, so it would be 20.29 feet, about, approximately. So that's how you would solve something like that. Most of the word problems are not going to be this in-depth and this detailed, but in case you ever see any that are like this is how you're going to solve them. You don't switch the letters like you normally would. You would just go ahead and solve for r outright. And then if it tells you like it has a volume of 35,000 feet, then you're going to plug it into the inverse equation. Or if for some reason it asks you to find the volume of one that had a radius of something different, then sorry, don't know what happened there. I'm really having technical difficulties, so I apologize for that. But if it gave you the radius and it asked you to find the volume, you could just plug it into the original equation instead of plugging it into the inverse. So that's kind of the idea, is the inverse just like gives you an easier way to find stuff based on the information that you have. Because if you have volume, it's easier to plug it into this equation. And if you have the radius, it's easier to use the other one. So with that being said, things to keep in mind, and I'm just going to come back to my original. The x and y coordinates get switched. The graphs reflect over the line y equals x, and you're kind of like working backwards. You just switch x and y in the equation and then solve for y when you're trying to find the inverse, and that is all. So if you have any questions, please let me know. Otherwise, go ahead and get started on trying to find some inverses.